So online with me, I've got Robert Kryder here, and a lot of people know Robert as a Bigfoot expert, and what he's uncovered with the Bigfoot is unbelievable, and how they've tried to how they've suppressed the information that he brought to the community, to the academia. But we're not here to talk about Bigfoot. We're here to talk about treasure hunting, because Robert is also a treasure hunter. But he was telling me some things about some. He's Robert's a smart guy, and he was telling me about some stuffs he was doing for how to help the treasure hunter to find things better, deeper, and all that. And so what he was telling me, I thought, man, I don't really 100% understand it, but it sounded ingenious to me. So with that, Robert, tell me what you got going on, and I'm just going to say, take it away.
Well, how you doing, Terry? And I want to say thank you for having me on this evening. I think it's kind of just great hanging out with you, whether we're online or not. But I don't know if all you guys know how wonderful a guy this guy actually is, and not for having me on here either. So thanks to him, I ended up with this cool Christmas card here. Let me see if I can get it down without making a total wreck, right? So without him, I ended up with this cool Christmas card from the old folks at let me get it where you can read it at Phenomicon.
Awesome.
Yeah, isn't that neat? And that was all because of Terry here. I ended up speaking over there. So I'm going to float him credit from about here to eternity for that one. So I appreciate it.
Well,
So you guys, so
and
go
my
ahead.
all my credit is due to knowing people like you. So I have no what do I want to say? I have no credibility or anything other than I just know a lot of great people like you, and Robert, you're one of them. So
Well, I don't know one of them who thinks bad of you anyway. So, but yeah, to get to the point, what we did was we put together, I guess, based on our own damn need. So to tell you just kind of backstory, and I am not downplaying OKM technologies or anything that they put together. I think they're actually pretty wonderful guys. They got their way, and that's the way it is. So, but I fully believe in their tech. A lot of people had a lot hard time with their technology, even when they had all the user interface and everything was working right. They still were, and they still do have a very difficult time interpreting the scan stuff, because they can't tell you in a manual how to do this. It's not really almost possible to go over everything. And, sure, they'll show you how to, find metal targets. But when it comes to gold, versus a ceramic or a inert rock or whatever, I mean, they're very similar in what they signatures, and they just don't teach all that. And you're learning to use their early equipment. We got the first Rover C they put out. And of course, that was 20 something years ago, right? So it eventually they had sold license keys, which is one of those things. It's almost like planned obsolescence, and that's just their way, whatever. But I don't really agree with that. But anyway, we used a lot of license keys, this and that, and it ended up, computers crash, technology changes, and you go through and you end up having to pay a lot of money for these series of keys over and over, like 700 euro. And we just get frustrated with that. Well, eventually it got to where I couldn't afford that, and this and that. Life changes, and I picked up my machine again to use it after a few years, and I couldn't use it because my software wouldn't open on any of the new stuff at all. So I inquired about, okay, I need another software package, something to work with my device. Now these devices aren't cheap. I paid 12 grand for that one, 4,500 for a larger antenna for it, and it's a passive geomagnetic scanner, similar to a mag, just like on steroids. And but regardless, when I contacted them, they told me there was no solution, and they said, "Well, your device is 20 years old." And I said, "Well, no, it is 20 years old, but it's like brand new. I take care of my equipment; it works just fine. So where's the problem in just getting an old copy of the software? Pump me a license key, throw me a charge?" And I'm not going to say they didn't try to help. They really tried to help, but they didn't even have any of the old software on file. They had to go to the developer who had it in an old laptop and whatnot. And I'm not down on anybody, because they did take the effort to do this. And eventually they said they had a solution for me. But in the interim time, when we were talking about this, my frustration kind of hilted. A buddy of mine passed away. I went up to see his family, kind of at his wake. And I'm not a big funeral guy, but I'll damn sure go to a wake, and send him off. So when I did, though, one of my old KX cohorts, he's not old, but he's been around the team for a long time, named Taylor Mayhew, got to talking, and I told him, about the situation and this and that. And I know his potential. He knows mine. So we just talked about it and said, why don't we just build our own damn software? I bet we can get our software done before they figure out a patch in a way that we can get these old machines running. Because basically you're talking, $16,000, $17,000 worth of equipment is a paperweight, perfectly good working paperweight at that point. And to me, that's kind of ridiculous. That should never
And
happen.
and you're
But
100% right. I know several guys that had that, and they always had software issues, software problems, always had to update it. And you had to call to Germany, I think it was, to get
mhm.
everything up. And it was just a pain. So,
Yeah,
yeah.
and the reason for that is because and it's not necessarily, like I said, I'm not down on them. It's not a bad sense of thought to be, Apple does it. Let's put it that way, right? I mean, Apple's
Yep.
totally proprietary on every single Accord, off the charts. But to me, if you run a scan, you should be able to take that scan data and put it into any software application, a spatial software application you want to. It should be formatted in a manner that you can do something with it. Why would you prevent the analytical work from being done, cross-technology analytical work on that data that it takes to really get good answers, right? Why would you prevent that? Just trying to stick them with your own stuff. Now, I'm not saying bad or good, but that is a frame of mind. And it's a certain marketing frame of mind that actually a lot of companies from the 70s up, 60s up, they went by that model. But anymore, it's more like the Elon Musk model, where everything's damn near open source. If you think you can do it, tear ass and get after it, because we're going to be ahead of you already anyway. You're picking at our breadcrumbs. Well, that's where we're coming from this. I'm not saying, try to hack our shit, whatever, because anybody could do what we do. And it'd probably be easier to set it up from the beginning than it would be to try to crawl through our program. But needless to say, we were successful in doing it. And what I did was not just try to solve the magnetometer or the deep earth image scanner or anything else. See, this answer provides a solution to image with just about anything. Anything that creates an audio tone. And most of the equipment, almost everything out there, except some of the modern OKM stuff, and I talked to one of their developers. They had never considered this, so it's not like they tried to prevent it, but generates an audio tone. You have headphones that can go into almost anything, underwater detectors, two boxes, mags, everything else, still generate an audio tone. What we have found is none of these use basically an algorithm to make a tone that's different than the data. So they're really just producing whatever's coming off the coils, whatever it is, whatever's happening there is just directly being converted to an audio tone. So all the data is actually in that. If I show you, in which we can show you the amount of data, I don't know what'll happen with the microphone when we go to do this, but we'll see, right? That's what we do. But the data, the amount of data that's actually coming across in that sound wave is incredible. And so but of course, every single device out there produces a different tone, amplitude, frequency, the way that signal is handled. So we had to develop software that can adjust around all that you could really simply fine tune around whatever device you're plugging in. Being that said, now you can take a metal detector or an RF machine or whatever that's not got any visualizer or 3D analytical software or viewing software available for it. And now you can plug that detector into our software and map with it 3D, just like an OKM scanner.
And to me, that's absolutely brilliant and crazy to think that you could take your regular metal detector, your regular tube box, and turn it into something that will map what you're scanning for, because mapping it, man, I can see all kinds of possibilities. If you can map what you're scanning, you just opened up a whole new world to the treasure hunting world.
Yeah, absolutely. I mean, I can map my kid playing guitar. And that's true. I can take the sound waves and make a 3D map out of it. And so it'll allow us to do it with anything. Now, I know I sent you something earlier, Terry, that was kind of a behind the scenes thing. And I'm not going to quote it, but what we are talking about that we're going to be able to do with this technology is way beyond what I think anyone even up to this point has considered. We see a lot of other fanciful developments in technology like 3D scanners and other things, and they're flying, man. They're cruising. And you look at what they're doing. You can take a smartphone and take an object or go into a cave and photogrammetry map the entire thing within millimeters of accuracy. And the more you go over it, the more it refines and makes that image accurate, right? Well, we have discovered a way of doing that with metal detectors, two boxes, magnetometers, and putting them, all these different technologies can go into the same data set even, and just enhance and comparatively using AI deep learning to distinguish all these things in the fields. So eventually, and where we're headed is, instead of seeing like every bit of scan material in the world shows you the waveform, and if something's in the way, like a boat sounder, it's bouncing a wave and you see something, instead of kind of seeing it that way, we would actually see the objects in 3D space, voids in 3D space, mineral bodies in 3D space, and the AI would be interpreting all this, right down to aged mineral crusts. So if you have an item that's buried in the earth for a long time and mineral crystallizes on its surface, we will actually be able to look at that stuff and date it without even digging it up.
Really?
Now, none of this would have been possible without the most advanced AIs. So we are using some of the most advanced design AI out there, period. And it is working with us to find ways to do this. Now, Taylor is the guy that can make it happen. He's the code man. He can just, and he can see vision and then put it down. And then I guess I'm the guy who has this vision of what my fantastic sci-fi, non-realistic head wants to dream up with, right? The thing is, we know we can actually do it, and we did it. This is the start of it. And already on our, we put 3 grids down on our base software, and we'll show you this. But one of the grids is amplitude, one's frequency, and all these are run simultaneously, and they're flawless and they're quick and all that. And you can load and unload any grid from any position at any time. You can just reach in the files and grab the one you did yesterday and throw it on the screen and be looking at both of them. And then you can change them. So you can change them in the amplitude of the signal, the frequency of the signal, and then our lower map is actually what we consider 5D because it has more information in it than you can put in 3D space. And that information is being plugged in through, right now, very basic machine learning to assist in identifying straight lines, corners. And so it's already it's developing right now to be able to help find foundations, boxes, walls, holes. And very soon, this will actually get to know what backfill looks like. It'll get to know what wood looks like and feels like. So this program is more than you can visually see. It is sensing changes in the magnetic field in relation to everything else. These things, it can get to know the fine nuances of it and begin to structure data for us. So already our 3rd grid has a deeper data set than I think anything probably available out there. And we're learning how to look at it and analyze with it. And the first time I tried it was with my old Rover C, who's, like I said, it's been defunct forever. Plugged it in, me and the kid went out in the backyard. I went where I know we have a buried sewer line, but I didn't know the other details I was going to be able to see. And we were able to scan a 10 by 10 real quick and bring it up and be able to see not only the 4-inch plastic pipe and the backfill region, but you could see an old trench region where they laid it, and you could see a newer backfill region where somebody had excavated it, joined it to another piece of pipe, and there was a small leak there. So, and you could see the plume. So I know but the thing is, you can map all of that without any metals, in conjunction. So we're looking at plastic pipe. We're looking at, and right now we're seeing the magnetic signature, and that again is something that we're going to be teaching. So, with all this, unlike all the other stuff out there, we're like guys like you guys, man, like straight up. We're like everybody else. We're like, oh man, what the hell is that? What is this? And you're trying to Google and find people's videos and all this. It's not like that. You call us on the phone and we'll teach you.
Just so you know, I wanted John Madsen because he's my tech guy and he's smarter than me, and he would understand more what you're talking about, but I got him on speaker so they can hear what you're saying. So if he's got any questions for you, I'll have him pipe in.
So just to give a brief run, and then we'll catch up to where we were so John can catch up to us. So this software is basically going to enable anything that puts out an audio tone to generate a 3D map. And when we're talking just now about how this is achieved on our charts and graphs, John, what I was telling him was about our visual display on our interface and how we show 3 grids at the same time and how you can switch these any file to any grid. And one of them is amplitude, one is frequency, and one is what we consider 5D smart grid that's using machine learning to help interpret foundations, walls, and different objects and materials. And that's where we kind of left off. And so to take it from that point, so let's say you had $100 detector and you plug it into this machine. You don't use it as a detector anymore. Well, not at this point. We'll get into some further details in a sec, but you don't use it as a detector anymore. You now use it as a ground scanning device. So depending on the detector you use, we develop methods for you and with you that you can achieve straight and accurate sampling with it. So, because I mean, some have all metal modes, some have all manual mode, whatever it is, we have to adjust our methodology around how that machine wants to sample data. And we figured out, of course, a way to deal with all of these issues. The interface is really, really easy because once it's receiving an audio signal, it allows you to tune it. And I'll show you that too, and be able to easily bring that signal in. And then you can scan live and it'll count down whatever you want in distance up to 100, and then you can go 100 sideways basically. So you'd run a line, you go back, run the next line, run the next line. OKM and a lot of other scanners, they want to get motion so bad to be cool that they'll run you up and run a turn and come back and a turn and come back. And it is literally impossible unless you're a machine to make that turn in the same time that you're progressing your line and without wiggling the machine. And all that causes problems in the data. And so if your turn is a hair slow, your entire next line is going to drag behind, and that will be worse every line that goes down. And you get what a lot of people get, like banding and a whole bunch of other crazy interference in there. And our software will not do that. You know where you are when you're there. So that's the whole point to it. We are going to have in programmable sample rates too. So you can sample 10 times or 100 times per second, or up to one. Right now we run one pulse per second on scans, and that achieves beautiful results. But if you wanted to go into 1-inch resolution, then you could be able to set your sample rate at I think just 12, basically 12 times per second is going to give you 1-inch resolution, and we want to take that up to about 100 samples per second.
So you were saying before I rudely interrupted you. You were saying about you took a scan of your sewer line, you found where there was a leak in that, and you used your OKM for that.
Yeah.
That's made to go deep. How deep will a regular metal detector sound down? I mean, is it limited? It's limited still by the depth that you go.
Yeah, so it's limited by 4 or 5 factors. One being the transmission coil, its efficiency, the reception coil, its efficiency, the physical coils and how efficient both of those are primarily. Then it's output power, receiving power, and just like a CB or anything else that uses RF. So you can amplify the output, you can amplify the receiver. Of course, the more you do, the more they pick up all kinds of other stuff and interference and whatnot. The depth also then what regulates at the outside parameters like the soil conditions and how mineralized the soil is, and then the frequency of the detector. So because lower frequencies travel much greater than higher frequencies on an exponential scale. What will happen at 100 kilohertz versus 6 kilohertz is a tremendous difference. A 6 kilohertz detector, you could dig for hours to pull up a bronze needle, and I know I did it, like 4 hours, because there was a rocky area and the signal was bouncing off every single rock, and every rock you pulled out, the signal changed. And so because low frequency was literally just making its way through everything. So that's really the defining factor. Now there's, I don't remember what the model is, I could look back, but there's actually a Chinese detector that I was just told about by one of the OKM developers that has a tremendous depth, like 12, it's rated like 12 feet instead of 18 inches.
Really?
But I don't know if it's FCC legal either. And there we come into the output, the wattage on the detector. So I think there's a 5-watt max right now, and a radio station generally puts out 25. And hypothetically, we might be working on stuff up to 100, but that's all hypothetically, right? So who knows? But the point being is that the megahertz that you're running is your depth as well. Um,
if you make
I don't
sure
know
it's
what kind of audio we've got in the background, Terry, but
Yeah,
and
this is
then,
John talking. Can you?
oh, go ahead, John.
yeah. So if you shield it though, you can go higher, correct? Like
Yeah.
just shield it. I know there's a lot of regulations. As long as it's shielded, you'll be able to crank that up even more. It's unshielded, you're really restricted.
So you mean shielded? You mean so that it's just basically just going down into the
Yeah.
ground and not going sideways and up in the air and all that?
Yeah. Yeah. Use either a reflector or and antenna configuration to focus your signal down instead of out. Yeah. And that's kind of what we would be, I'm sure, doing anyway, because we want to, well, I'll go on to where we want to go here in a minute with it, but we're talking about right now kind of where we are. And the unique part about it is what you can use in even the OKM stuff, it's really just a mag. And its mag's got, it's picking up frequency in the EM field based on its orientation and whatever else is around and under it. And it's going basically up and down in frequency, but its pulsing and its amplitude are also changing. And that's something that a lot of people wouldn't realize. If you're using a mag with headphones or something like that, sure, you hear it going up and down, whatnot. But if you look at the data of what's in there, there's the amplitude or the power of that, and then the subtle changes in frequency mean a lot. They mean a lot. So we're actually able to see a little better than I've ever been able to see with the OKM software, because we're treating it differently. We're not treating it the way they do. They do it in basically, even when they digitize everything, it's still basically analog. When it goes up here, it goes up there. We're not doing that.
So I was just going to ask that with a regular metal detector, you got, if you have headphones on, you'll be able to hear that small tone rise when you hit something versus if you don't have it close to your ears. But what I think you're saying is your software will pick up that slight rise in tone even better than headphones would. Is
Oh,
that
wait, no, we can way better than a human being, because we can take tiny changes, and then what our software does is turns those into big changes. You see what I'm saying? So
yeah.
now, like anything else, it's almost like ground balance on a detector. If you peak it over here, you're going to devalue this in the scan data, but we have filters. We can just crank those down and up and change those balances and bring up whatever we want that's hiding in the image. So, and I'll show you, it's not difficult. This stuff works very fluid.
So I don't know how much difference that this would do, but it looks like to me that you could get a greater depth with your software than you
Right.
can just regular. You could get
Yeah.
a lot and more defined.
Yeah, because if the whole signal base drops, our software is just raising it up. So even a tiny peak is still going to show up as a peak on the data. It's still going to be a peak in the map. It doesn't matter how big the change is. If there's a change relative to its surroundings, there's going to be it's going to show on the map, period. It doesn't matter. And as well, you could potentially crank the gain on this equipment and be able to we can look on the graph at what you cannot hear with your ear at all. And we still see it on the graph. If there's data there, we see it. It doesn't matter how quiet it is. We still see the data. It doesn't matter. So our base is way lower than what your ear's base is to pick up those changes. And it's surprising how accurate, how good, and how smooth everything. We're sampling audio at 48,000 times per second, or 48 megahertz or kilohertz. And so that's very, very fast considering for imaging technology, let's say, since we're only gathering to generate our map a pulse per second. So if it's all data saturation, how big of files you want to create. We create manageable files that look good, that you can see everything on. If we want to jump the sample rate way the hell up, I mean, we could really go scale it if we wanted to. Take big computers to do that. But at the same rate, I mean, eventually, later down the line, that's where our future is, because we found a way around the big computers with AI's help. But that's down the line. But right now, yeah, so a metal detector can be used as a ground scanner, and your depth is going to be what it is. Now, each detector's frequency is going to be responsive to different things. So a frequency closer to what gold wants to ring at 70 kilohertz or whatever is gonna naturally, or 70 megahertz, whatever it is gonna naturally, yeah, kilohertz. I'm sorry. So it's gonna naturally ring with that better. You're gonna see that better in
Find
the data.
smaller. It'll find smaller nuggets.
Right.
Yeah.
Yeah, exactly. So like a MindLab multi-frequency that's doing this distinguishing for you is like a pre-software filter for our software, if you look at it that way. So if it's highlighting gold and it's sounding on gold, then that's what's going to show up in your map. So what we are doing here is able to, let's say you're out there that day and you got $200 MindLab Go 60 and you got a cheap mag with you, and you got whatever else is sitting there, 2-box or whatever you got sitting there, right? Old Fisher 2-box or whatever, it doesn't matter. And you don't have software for any of this crap, right? So I'm sure not that, and you got your metal detector and whatnot. So you can just plug each of these things in, go over the same grid, run a scan, and then compare your scan analytics to what each one of those machines is doing, and you do it all on the same screens. Each one of them is going to show you an image based on what they like, what they look at, what they respond to. A mag is going to give you that passive magnetic view into the ground. An RF emission is going to give you a view based on a magnetic field, the RF field hitting the objects, bouncing off, heating up iron targets, making them hotter than normal, and then being blocked or absorbed by other materials. That's still going to all show up in the data because it's all changes. See what I'm saying? So you can map in various ways with various equipment and either do it with one of the other what you got, or you can do it redundant against each other and get all kinds of information. And this is going to lead us to the next subject, if you don't mind if I go on to the device, and then we'll go back to the software and take a look at it. But if you don't mind, so we're also, is that good with you, Terry, on the time?
Yeah, well, let me ask one quick question.
Go ahead. Yeah.
Because you brought up a good point. You can take different pieces of equipment you got, a metal detector, a 2-box, a magnetometer, and plug it into your software, whatever you're developing here. How easy is it to switch from one thing to the other? Because they're different, they're looking at things differently.
Yeah.
Or is it just basically sound, and so it just picks up the sound, or how is that?
Well, it's just like this. Just to go through the steps of actually doing anything in the field, you would unplug the audio cable out of one device and plug it into the other device and hit start. And then there's 3 little sliders. And if it's got a lot of mess up top, you pull one slider over till that goes away. And if you got mess on the bottom, you pull one slide over till that goes away. And one of them is just overall volume. So if it's a real loud machine, you just turn it down a little. If it's a quiet one, you turn it up. And then you're scanning. That's it. So
Cool.
So it's real easy. That's what you'll see in the software. It's real easy, and it's real intuitive. Right when it comes up, there's your sliders, and then you move on to the next thing and scroll down. So all of our screens are on one screen, and we've made a long scrolling screen so that to get to your scans and everything else, instead of trying to do it all within this one region, you just scroll down and there's your next, and scroll down, there's your next. It's real easy to get back and forth between all your data and your scanning. So it's not one or the other. I've used a lot of different technology. A lot of it was as it was being developed. So a lot of these things didn't even have their software done. And, we did manual kriging of the data and all this others. And so far, I think overall, this is the easiest user interface I've ever seen. And that's why we set it up. And hats off to Taylor, because I'm basically just imagining, God, I wish I had this. And man, I'm using this thing and this pisses me off. Excuse me. And I'm using this thing and this pisses me off. And in the field, if you're not out there in the field, if you're in a facility somewhere in an R&D department and you're testing the stuff in the hallway outside, you're not going to be able to develop good interface or equipment, right? I mean, most put more effort into the looks of their case and how cool it is and everything else than they really do its functionality for a treasure hunter or an archaeologist or on a construction site. But that's where we come from. So I've got background in archaeology, treasure hunting, construction, and all these things, and I know what you want when you're there, and I know what pisses you off about it, right? So, but anyway, so if we can go on, I want to get on to the
Okay,
device.
let's go on.
Go ahead.
Let's go on.
We're also creating an app. So all this will run on a telephone as well. So it'll all be Android based. Apple's too proprietary for now. They don't like anybody else's stuff, and they're not going to make anything like this. But regardless, so we'll have a phone app here in the next couple of weeks. And you'll be able to use your phone, basically plug your detector into your telephone and scan. That's going to be what that's all about. And then as well, but we're creating a physical device. It's about about the size of a pack of cigarettes. But in there is a really advanced microprocessing unit and a bunch of other little goodies like Wi-Fi module and a GPS and all kinds of other stuff. But what this device does is take over and allows you to do all your detection sampling and things with the program built in the device and have GPS tracking and all this. So basically, you'll just Velcro this to the side of your detector, plug the audio cable into it, and then you'll Wi-Fi connect to it with a tablet, phone, laptop, whatever's got a Wi-Fi connection, so no cable to that, and then you'll do your scanning. And so there won't be any difference on the detector at all. It has a Bluetooth connection. It will be taking that data and taking it into the data, putting it through the program, and you'll see it on your device without using the resources inside the phone or inside the device, except for a Bluetooth connection. So, and that's where we're going with the base. And then we're already setting up now as well subscription types that we have a basic one for the guy who just wants to buy the app and then be able to open it, right, and just look at it and stuff. We have and then the subscription though gives you of your updates, and it gets you access to online tools with the AI, a basic AI level we'll have, to where you can upload a scan into the system and then have AI help interpret that scan and work on the scan with you. And as well, we'll have people on the even the base subscription level that can work back and forth with you to help you in your methods, your techniques and things like that. Also, we're having training courses. We've already got that started. I've got something set up for July 13th. It's going to be kind of a seminar out here where we're going to do a 2-day deal and go over all this and magnetic theory and show people what things look like in a magnetic field and in an RF field and things so they can interpret their stuff. Now, that's where we're at right now. All this will be out in pretty short term. This isn't far at all down the line. We have our softwares to our beta testers right now. We just started taking in beta testers today. We were only going to open up the door for 20, and I've got like 10 already barking at me. So we do have positions available for beta testers if anybody wants to jump on. And what we expect out of them is to just have feedback with us. They get to purchase the software at a reduced rate, and with that comes the app, and then comes reduction in 50% off for the second tier, but on the devices and everything else, and then as well on the big subscription and all that. And so our larger subscription package will have a lot more advantage into extremely high AI tools and our new development stuff we're going to be working on. We're going to do that through our higher end subscribers to that, because they're already going to be tied into a system that we can take back and forth data. And nothing goes anywhere. Like there's no information on these files unless you want to put it on the file. Like, and I'm doing that on purpose. It's like the device is set up so you can get GPS information and log it and store it in the device, but it never sends anywhere or goes anywhere. You don't need anything to be able to connect to that. And then if people who want to as well record and do these scans, whatever, using an audio cable directly into a laptop, if you're not online, it's impossible for anybody to get that data. And that's kind of where we want to go to, because I know a lot of guys are nervous about how it can they glean metadata or location information or anything off these files. And we've been really, really picky about finding ways that can't happen or doesn't happen unless you choose to. So, we'll have Google overlay too. The whole program will be where you can put your Google overlay image. It'll show you the square of your grid, what the ground looks like and what the topography looks like and all that stuff. And then, and as well.
So man, you're just saying that you can log in your GPS locations of what that picked up, where, overlay it on Google Earth and all that stuff, man, sounds like an incredible deal to me.
Yeah, and that's right around the corner. All that stuff's right here. We already have all of our boards and everything for our thing. We're just right now finalizing placement of the boards and the case and all that stuff, and then the flash programming into there. But we're right. That's all right around the corner, and that's what we consider the easy stuff. Where we're going with this is, imagine you had a detector head And as you sweep around anywhere in any direction, it's mapping whatever the hell its field encounters, back and forth over and over from the full field kernel. So you have a round field, and as that round field passes over an object, it sees it this way and this way from the detector head. Well, now you see both sides of the object, under the object, around the object, even under the object, all the way around. So what we're using is creating a phase lock loop and then ringing everything in there, so to speak, and analyzing the harmonic feedback of just all the stuff that reacts to whatever we're broadcasting. Doing this will enable us to imagine going into a cave. And today they can go into a cave and they take a 3D scanner and they set it up and it scans the whole cave. It's very complicated and everything. And now it's got to where we can take an iPhone and go into the cave and just about do the same thing. Well, imagine doing that, not only mapping the interior walls of the cave, but mapping 100 feet deep, 3D, all the way around it as you do it. And then being able to visualize that on a map in a 3D space without a grid.
Wow.
So we won't even need a grid, and we'll be sampling at 40,000 times per second with no grid, with no 3D spatial mapping system. It will all be AI controlled. So what the AI is getting this information, it is seeing, and then it draws for us what it knows that is. So our comparative analysis with the AI, we did what you'd call kind of a virtual test. So we did a test with, as if it was the real world in a virtual atmosphere with the technology already. So we're already at this point. And we determined, and the AI determined, that if we had a room buried in the ground that was 10 feet deep, and it had in a sediment soil, normal sedimentation, and it had stone walls and was filled with layers of clay and sand and had a ceramic pot in the center of the floor, what could we see? And the AI was fully confident that if we did everything that it said it needed, and we provided it with each thing, which is totally doable, that it would be able to see the difference between the stone and the sediment around and identify each as what it was. It would be able to identify the depth to the hollow, even if it's backfilled. It would be able to identify the depth of the strata and that it's sand and clay. And then it would be able to not just identify the ceramic pot, but be able to model it in 3D and be able to read its mineral crust that it gets from the age of being buried.
Really?
Without digging it up. That's
Really?
where we're going.
Wow. So what kind of a detection head would you have to get that kind of depth, to get that kind of accuracy, to get that kind of
100-watt, 100 megahertz focused broadcast coil and receiving in it. So you could still build it in a handheld detector rig. It's a little hot. I mean, I don't at that level, that much radiation, I don't believe would be dangerous. We'll have an EM team study and all that, and it's probably just simple to look up now. So I don't think you'd have to wear any shielding to run the thing. But
well, it's like John said, if you build it with shielding on it, of course,
right.
if you're in a cave, it'd be great to do it, all the directions all at the same time.
Well, if you're gonna be in a cave, you're gonna still get a lot of radiation because not everything's going in the ground. A lot of it's gonna be bouncing off and bouncing everywhere in there. So, but a lot of it's gonna get absorbed too. And low frequency is wonderful because high frequency is usually what's dangerous. Low frequency you can play with. So it's. I mean, there is infrasonic stuff and things and considerations, but we just map it and see where we go. If in the initial sum, we are not going to be building the big broadcast devices and equipment. We're going to be doing this same tech with whatever you've got in hand. So we're going to be applying this AI to your metal detector and to all this other stuff, and that's where we're going with the higher level of our subscribers, and stuff.
So you were saying that you could scan all directions over something, and it's going to know that you're scanning different directions and finding that same thing because it's picking up that same thing. It's mapped its shape, it's mapped it, and so it just
keeps adding to it and adding to it.
Add to it. If there's a say you're scanning a nail and then there's another nail right next to it, it's going to be picking up both nails, or how
Eventually,
would I
yeah,
know?
right. Where a normal detector, you'd only hear, or a scan unit, you'd see like one or something. Eventually, it's going to be repeating enough data over that scan, right? It would refine it down to two nails. And what the good part is we're doing it within the AI. We're letting the AI tell us, if you build me this, I'll be able to see this. And so we're building it what it asks for to be able to do these things. It's totally backwards from the way engineering's been done in the past. We decided what we want the components, software, and equipment to do, and then we try to envision this through their brain. Well, they know if the AI understands what you want and it says, well, I can do it if you give me this, this is what we're doing. And the refining of the image would be just like a 3D scanner. The more you go over it, the more angles you go over it, the more information it gets, the more it's going to be able to refine it. And it's pretty simple, really, because it's just whatever repeats itself and stays the same, it adds to. So eventually you get tons of data. But with AI, if it's seeing what it thinks is a chest and the materials are coming back what it believes is wood, then it's going to draw you a wooden chest. Now, how accurate that becomes after a while, and we'll have a slider that regulates how much AI input you want into the image. All that's doable today. And the way we're doing that is it's simple. Drones do it every day and with extreme accuracy. We're going to basically use the same type of technology in a drone and program that into the head of a unit. And then that'll be RF shielded because we don't need it to communicate. It'll be a cable, so you'll place it on the head of your detector and it will track the motion, any motion, up, down, sideways, rotational, everything of the head. So it'll know exactly where the head is in 3D space all the time through real high-end gyroscopic technology. That way we don't have any interference down there on the module. And then if we RF shield it in a non-metallic RF shielding material, then we're done. So, and like I said, this is where we're going. Right now we have our project plan and we're very, very set to that plan. But at the same time, our future R&D is incorporating. So as we reach levels in this, it opens doors to that, and that's what we're doing.
So I know, man, Robert, that you're a smart guy. You figure things out to make things work for you, and I don't know if there's anything like this. There's nothing like this on the market now, is there? I mean, that's
not
why
like,
you built this.
yeah, that's why we built it. So it's just, first it was to answer the frustrations, and then it's like, hey, where can we go? So then it's to answer the call of your dreams, right? So this is where we're going to go. How far can you go? We're going to go absolutely as far as modern tech will go, period. And even with what we've done right now, this file, you guys are going to flip how small we've got this program. It was huge, but Taylor's a master, found a way to refine it. But we're down under 1 megabyte. So it's a very, very small and extremely fast and operable system. So to have it on, to start it and have it sampling is less than 2 seconds. I mean, I haven't had it take over 2 seconds yet, period. And 1 second to start, to get going. So, do you guys want to take a look at the software? You want to?
Yeah, let's take a look at the software. But first of all, John, you got any questions?
Yeah, well, just a couple. Have you been able to test how well it does with depth in different type of soil samples at all?
Not a lot.
Like
Just
in clay, and I mean, because you was talking about finding this room that was in clay and stuff like that. And clay is a definitely killer for things like ground penetrating radar and things like that.
Yeah, and fortunately, the Earth, like magnetometers and low frequency detection equipment, don't really mind the clay so much. It's a good conductor of low frequency because you ring it here, it comes out over there. It's good for that. It's not good for high frequencies. And then depending on how mineralized the clay is, a lot of clays can be really mineralized, some are inert. And then some can have rare earths in them too, which like blue clays, a lot of those have rare earths, and then those can really throw RF off. But the room, of course, is a hypothetical virtual trip that we did with the AI, based on what we were going to do in the future. What we're doing now, and when we talk about depth and how we've been able to do it, no, John, I haven't been able to do a lot of testing anywhere other than the control that I have, and mainly because I wanted to see if I could see soil density changes and the lack or absence of an magnetic field, like from the 4-inch plastic pipe, because that's not really a very big signature of absence. And that appears to be, it's actually pretty deep right there. It appears to be about 6 feet deep. or 4 to 6, I would say, based on. So we will have very accurate depth representation. All we have to do is basically find those parameters and then tell the deep learning grid what that parameter is, and then it will identify that for you. I mean, it's going to be it'll scale it on the density and the dielectric properties. So,
Any other questions, John?
At this point, I'd love to see it.
Yeah, it sounds okay. Robert, let's dig into what you got there. Let's see what you got there.
yeah, we'll bring up the text. So, can you see that good there, Terry?
Yep, I can.
Okay, so this is our control interface, and you can see the whole interface on the screen. Yeah,
Yep.
okay, I see that. So I'm going to show you this is how long it takes to start collecting audio. Well, I have to actually do it on the program. I can't do it in my other window there, do we? Okay, so you can still hear me, Terry?
Yes.
Okay, so right now it has no conflict. It is using the microphone that I'm speaking to Terry on and creating a sound image. So I can create a grid off this image if I was to choose to, no problem. But what we were able to do is, let's say that this is just too loud. It's really, really loud. So I'm going to take my gain slider and I just cut it all. I'm going to turn it down. So I can adjust my volume with the gain slider really easy. You can see I'll make a kind of a shh sound, so you can see shh. So these sliders are very fluid. Now, this is a high pass filter, of course, so I can knock off just the upper frequencies, and you can see them falling as I move them on my graph, and I can take them down to a thin line. And then my low pass filter, of course, I can start taking out my low ends. Well, I take out everybody there, and start canceling the lower frequencies on the graph. And then let's say this is where so then you see how clean I can sample data. So this is how you tune to different machines. Once you tune to a clean signature, you're good to go. Scanning is literally, you want to do how far you want to go. I want to go 10 paces, right? So I set 10. This is my timer. This allows me, if one person's running a laptop for now, this allows me to set a timer before I go start my scan. I can do this all the way up to a minute. So you can get in position, get all ready, do everything else, and then it'll automatically start your scan for you. You don't have to do anything else. You hit start. That's it. It'll scan a line, and then when it's done with that line, it'll move the Y position, which is to move over a line. It'll move that over automatically. You don't have to do anything other than that. Move over to your next line, hit scan. And you do that, you just hit the green button for each line you want to make. And it'll follow what you told it to do, and it'll create all the files for you. And then to open a file at any given place, let's see, Geo Pro files, what do you want to open? Oh, we'll open test one because that's a generic pinpoint file. This file was actually created with my Rover C, and it's a controlled file, so it was done with the magnetometer, rotated 90 degrees or 45 degrees, I think. So that gives you this value difference in a specific spot. But you can see how clean our signature is. There's not a lot of because we didn't move the unit. It's absolutely perfect. If we move the unit at all whatsoever and make changes, those changes will be represented. But right now, I'm just going to show you the test file so you can see the comparative analysis on the grid forms. So the one on the left is your amplitude. The one on the right, or I'm not sure which way it shows up on your screen. I think we're reversed on your screen. I don't know, Terry. But either way.
So the red one's on my right.
Oh, it is. Okay. Then we're good. So yeah, so the left one is amplitude, as you can see, and the right one is frequency. And in a situation like this, where we have just a simple tone generated, we don't see a whole lot of difference in this map because visually it's not going to look like a lot. There's a little different frequency change than there is amplitude, and you can see it in the color banding. But that's where the lower grid comes in, because this is a multispectral grid. This is the one that uses machine learning, and it's going to look quite a bit different. And it's going to give us a lot different data sets. Now, the top image is not our scan. That is being created by the machine learning. And with this is a very simple pinpoint, so it's not really going to dramatize this very well. But it does show you that what we're doing here with data sets. So 3D would be just this. but the colors in this is a fourth dimension. And then the spatial, I want to say relationships between these items is a fifth dimension to the information. And it's learning to use this. We're even still learning to use it, but like if I would want to turn on a low pass filter, and even the first level, it changes the relationship of this information. And this is where we're going to get our depth. So we are programming it to give us accurate depth representations based on things. And what these filters do, you'll see there's not a lot of change once I do that. Now there will be change in it, but it's only going to happen when it gets to a level when it declares it. So right now we would look at this and say, wow, our filter does not change past that point. That's probably an accurate depth representation. Of course, the high pass, you can tune the high pass as well, and it gives you another data set of information. So it wants to stop right there on the turquoise level. That's ways of basically just analyzing what you're seeing. And if I want to bring in kind of a more complex scan, and this is the freedom of this stuff. So, it doesn't matter what scan I've got up here. We'll try this one. We'll just see what this is, a test file. So this is a test file of what would represent a line scan. And you can see as well, it's giving another spatial ID, but this is going to be probably a little more dramatic when we see our scaling because we have so many value changes. So this would represent a cavity, and this would represent an iron object laying on the edge of a cavity. And so if we crank up our low pass filter, we begin to see, we can measure our value of our iron chart. And what this is doing on the bottom is it's got a real dimensional quality to it that doesn't exist up here. And so this is giving us other information. And since this is it's kind of a fake signal, we signaled this on purpose and built the data to replicate a straight lined iron target on the edge of a void. And that's what we're seeing. But we were able to measure it this way. And this is basically OKM's stuff does this automatically, but it doesn't give you a choice. And that's why it shows all their peaks and valleys are all below the scan level, the data set level. So we're able to do that. But anyway, but the whole thing is you can crank it and use your low pass filter and then get more information and measure the strength and stuff for your iron targets. And then depth, of course, is going to range and in your scale. And what we're doing is programming these values, and these are all going to change based on material density and stuff like that. So as this smart grid setup learns and we can teach it information, then it's going to get better at distinguishing this stuff. So it's actually figuring out what its depth should be based on the information. So now, as you can see, we've calculated a little. Now when we go back, it doesn't look like when we started exactly. And that's really normal. That's because it's done calculations in the graph. And then we do our remeasuring, and it's going to change the way everything works. So now our depth can go down and measure. So if we have green on the edge of our graph, so we have green at the top, if we go place this in the green where the sides touch the color value, this should be an accurate representation of depth. That's what the machine's trying to tell us. So, like I said, and then you can see the linear feature. These features have not changed, but the linear feature to the iron has. And so it's just learning how to read these scans I don't have the sewer one in this computer, or I'd bring it up because then I could show you. It's in the laptop, but
so this one right here you're showing, this is just kind of a mock-up. This isn't actual scans of things. This is just kind of a mock-up to show how it works.
Yeah, now these are scans, but they were done like this one was done on the floor, sitting here next to my computer, and in a very small region, 5 by, I don't know, whatever it is on here, 5 by 5. So there's only 5 pulses. So this is like 1.5 feet or something I did. Yeah. But that's a nail in the data, and we can probably, even on this, without the deep learning, probably bring that down to a nail signature, depending on how we use our filters, even now. So if we look at we can look up here at the top and see where we end up with this, but we'll turn on a low pass filter.
So in this program box that you get that you plug into your detector, how is it analyzing and using AI to figure out what you've got going on, or is that something that's in the mother um whatever, and you plug into it and analyze into it, or how's that working?
Well, this is all there is. You plug an audio cable into your laptop, plug it into your detector, set the values, and that's it. It's going to it builds all of this off the audio signal. So, this would be a void, under the floor. This is basically a little hollow spot under my floor.
Uh-huh.
And this is a nail in the floor. And as you can see, I can start, if I draw this down and bring accurate depth, it's going to be way shallow. And we're at 0 right now. So our 0 plane, it's a little large. Our total depth is maybe, 6 inches or a foot here. I only did a foot wide scan. So it's already showing me that a pretty accurate representation. If I want to drop my scan height, I guess we're all the way down, aren't we? So I'd probably have to bring my low pass one more and my other one down a little bit. And then it would eventually, we could draw it down to a little circle using the filters. But so it's already pretty well standard where it is, and it's giving me a depth here to that piece of metal in my floor at, half of my grid length. So, 6 inches to
Huh.
that piece of metal, whatever that piece of metal is that's there.
So you're set up to kind of like how some of these other imaging things are, is um, blue is kind of like a void, or
Yeah, we did that on purpose. Yeah.
red is kind of like some kind of a metallic object, or
Yeah, and we did that on purpose. And even in here, so absence of a hot magnetic field, positive on a hot magnetic field. Depending on your detector, this is a magnetometer. So it goes hot over iron targets in a magnetic field. So it gives an almost identical representation.
okay.
Um, of course, it would work differently with different metals because they wouldn't be magnetic. You'd still see silver because there's going to be a response. Silver has a deadening effect to the mag field. You're going to see a drop in the mag field, kind of a void signature, but it's never going to go into the blue. Based on frequency, it's going to end up, up here just outside the yellow, just in this zone kind of here. Zone gold for these frequency charts would normally end up in your turquoise color. But of course, you see turquoise values between other values. But if you look, what I'm doing is plotting. So when I go pinpoint like this, or on this map, you see shows up as little details show up on the 2D plot on the bottom. Often that's so you can take a look, but those don't normally show up. But what I don't see a void here because those are not standing out. This, if there's a void there, this is going to create a void signature. You're going to have a dive here and everything else. But what it is telling me is I have a lot less density here than I have over here.
Hmm.
It'll map that subtle of a change. That's kind of why we're doing it at this level. Like OKM stuff wouldn't be, if I did a foot scan right now through my floor, I wouldn't be able to see all this.
Wow.
This side would just be a big red side, and this side would be a big green side. But this cuts the data down. It chops the data down.
So the guys with the old OKMs that their softwares, they can't, they've had to pay a lot of money to update them, and now they got to update them again. They can just take that what they've got right now, plug your into it, and they're up and going again.
Yeah, and I think the ones that'll profit from this the biggest in user ability, that's going to have really the largest, return on their investment, the largest ORI is going to be those that have equipment that's defunct, that no longer will transmit, that they can't get to link up, that they don't have software for. If it puts out an audio tone, your $15,000 paperweight is now 100% usable again, and you're even going to be able to do more with it than you did before. So a lot of the equipment, I mean, every Rover C, the first generation that's out there, is a paperweight. Every one of them.
Yep.
The second edition are paperweights when the program fails. So and that's that. I mean, and they tried it. OKM's real good about working with people, but it's just because the rate of progression in technology of these computers and the laptops and the tablets and the
Yeah.
iPhones is so fast, their systems aren't going to deal with it like that. You can put this in anything. Anything will run this. So, and that's the point. We base this on HTML and Java. This is the base underneath this that runs this high tech crap is literally 30 something years old. So, but it's modernized in the extent that it's designed to run on all new systems, graphically and display and all that, and with, interacting with the microphone and all that stuff. Right now, the only issues we have on this version, which I'm already been releasing on the beta stuff, this is the one that people are going to be getting, is when we create files only in this version, it starts generating a lot of windows for each scan point generates a save window. And that won't be long. It'll be tomorrow or the next day. Taylor's actually working on it as we're doing our show right now. That's what he's working on, is getting it to allot those files and stuff. And so this software is also super cool because if I want to, and I want to change a value in this scan, I can just open the file, change a number, and change the value anywhere. If I want to redo one scan point, and if I look down here and go, man, that scan point was messed up, and I wish I could just scan one point. Gosh, dang it, I messed the whole thing up. You can do that in this.
Huh.
I can open this file like we have, right? And I can go up here and I can enter what X and Y position I want from the map and take 1 point. Go over there and stand and save 1 point. This is a point save. This also will change. It says point save on the later. But you save that point, and then you go open that in your downloads and open that file, and that change will be in the new file. And it doesn't change the old file. It'll save it as a new file. So, or you change your file name, but it won't alter what you just loaded it from. It'll just save you a new file with your change on it. So you can alter anything you want to. We can rescan. I can scan this one line and add it back to it. Another thing this will do that I don't know if any of the other ones will do it. So this is a true representation. So if a grid, let's bring up one that's not. This one a 3x5. Okay, so like this, if I run two lines, right? Just two lines show up on the grid.
Uh-huh.
If I was to load that same file above, it shows up on the entire grid because we're measuring amplitude. We don't need that to be graphic in nature. This isn't our location grid. This isn't what we use to pinpoint. We can, no problem. But this makes it graphically represents the data as it is on the ground, like to a T. So you don't have to run a full grid. And this grid will expand. It'll expand to 100 by 100. But if you run 10 this way, it's going to run you 10 this way and just open, but it won't stretch. So this is, it changes the data set to be representative of what's really on the ground. So what do you think so far?
I think it's pretty cool. So I'm trying to think for an advantage of a metal detector, though, because I can see it would let you go a little bit deeper with a metal detector just because you're not hearing the tones that this software would pick up.
Right.
Is there any other advantages other than that for a metal detector?
Well, yeah, because with a metal detector, you can't measure ground densities and things like that. So metal detector is used for metal. You can generate a 3D subsurface map of the ground with a metal detector with this. Because as you go over different soil densities, compaction, all that's changing the signal in the detector. So why would you pay attention to just barely up and downs? You listen for a ping, right? Well, if you scan an area, those barely up and downs become a map of your backfill, voids, rocks, things that don't show up on a detector, ceramic vessel. If you have some types of ceramic vessels, if you have metals in them, you're not going to hear them with the detector because the ceramic can shield the RF.
So with this on a metal detector, you would find other things, clay pots, fig trees, whatever. You just see whatever's in the ground. And I guess because of the density of it, you'd be able to tell a rock versus a uh, uh,
Density and
plot.
its relationship to magnetic field. So how does it act around an RF field? Does it shield it? Does it absorb it? Does it re-emit it?
Ah,
Reflect it? Broadcast a second field? See, iron is super hot because when you hit it with one RF, it actually doesn't reflect it. It throws off another signal. And then detectors read that second emission to see what it is.
okay.
Because gold doesn't do that, but gold carries electrons on it.
So,
And
so
so there's a whole different trip going on in the relationship of the
okay. So
RF.
this will turn your detector into to way more. So on a
Yeah,
regular metal detector, you turn that audio so that you can just barely hear it, so you can hear the rise or the dip in the
right.
tone. So on this, you'd want to maybe
Yeah, you can crank it up and then you go into
crank
the
it up so that
right.
this would see better.
Yeah, and so when you crank it up, if you like, we'll start the grid again. You can see everything's flawless, start, stops. But so on this, if you crank it up and let's say you have a bunch of echo because it's too high, leave it high coming out of the detector, and then you just crank your gain down and start reducing your gain. And here, this is why we have these tools, so you can fine tune all the garbage out. So you can leave high volume and not get the echo and everything else and get as much data as we can get in. But like I said, you can crank this way down to where it can barely hear me at all. And I mean, it doesn't even hear me, and it'll still draw a line in the data, even if it's super quiet, because it's the only thing there. It
Yeah.
doesn't matter. It'll still sample the data, even if if it goes over zero, the data knows it, and that's it. I mean, I barely got it turned on, and I could barely make a sound, and it registers, and it's not even picking up my voice 3 inches from the mic barely. And so that's why I say your sensitivity, you can do whatever you want with it. You can go basically anywhere you want. I mean, and that's what I wanted. If it didn't work, it's kind of like I didn't create this for everybody else, but I know it's a dream thing for everybody. I created it for me.
You everybody else needs it too.
Yeah, I mean, they're going to want the same thing I want. I created and Taylor created. I'm going to give him full credit for all this
So
fancies.
so
So,
so bottom line, basic, you seen a need, what you needed, what you wanted, you build it for it, and you can see that there's an advantage to everybody else to having this because you're a treasure hunter.
yeah, I mean, and stuff like this pisses companies off, to be honest with you, because they kind of rely on, hey, you need our stuff, period.
Yep.
You need to spend 10 grand or you're not going to get an image. I don't know what the guys in the scanning industry are going to think about it, because right now, it's $10. Well, when I was doing it commercially like 15 years ago or whatever, it was $10 to $20 a linear foot or square foot. It doesn't matter. It comes out the same. Um, and so, on a construction site, it's $10 a linear foot. On the side of a mountain, it's 20. That stacks up really quick. A 10 by
Yeah.
10 is $1,000. They're not even playing, right? So you can run 100 10 by 10s with your telephone. You know?
Wow.
So what are you going to do? So it's going to bring, even if it's basic scanning stuff and you're only getting, let's say your detector's rated at 18 inches and this pushes it to 24. It doesn't matter. You're ground scanning everything there 24 inches deep. It's What are you going to do to get an image in the ground 2 feet deep, to be able to see in the ground 2 feet deep, not just like pass it over and, you know what I mean, hear a tone. You're
Right.
ground
You're
imaging,
taking a
period.
picture of it. You can lay it out and look the whole grid over and see, huh?
Yeah, yeah, and we haven't tested. Like I said, it's due to the frequency and the wattage of the detector and the efficiency of the coils. Um, my White's Classic 3 from back in the day was developed by a certain individual that worked for White's until they got in a big fight and he quit them and whatnot. But the reason was because he was a little prodigy. And this is a 6 kilohertz detector. And like I said, it's a pain in the butt. But you know how far 6 kilohertz will go, even at 5 watts? I
Oh,
can pick up big targets at 45 feet. It'll ring big targets of gold at 45 feet. And so it goes off. If I crank it up, it goes off all over as you're walking on the ground. You can crank it up. You can hear all these changes, woo, 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 as you're walking with it. This thing's going to map like crazy. I already did one. Matter of fact, that one on the floor, that's my detector. That's not the rover. The one I said I did with the forced deal on the floor, that's my White's Classic 3 metal detector that I mapped that with. So you can not just see the nail, you see the density changes in the soil underneath the floor with my metal detector. So if that was a clay pot or ceramic or something like that, you'd have a defined edge. You'd actually see that target, yeah, that you would never ever know it was there. That's the key, really. We're opening the doors. So everything that limited me, I don't like to be limited. Everything that limited me pissed me off, and everything function that didn't work pissed me off. And then the dumb stuff, you go, why in the world did they do that? And why didn't they just do this? And we all look at programs and we all wonder that stuff. And it just comes because they got a different brain. Developers in that nature have a different brain than guys out there digging holes. So that's why the buttons are big. It's simple. You can't mess it up. Everything's easy. So, and that's kind of the whole point to this deal. It had to be done to where anybody could grab it. And, having the spectrum analyzer on the app, lets you just see the sliders and you can see what they do. It's self-explanatory. There's no learning curve. It's kind of like, okay, tune it to where you get the cleanest signal you got and then hit the green button after you set your, file name and how big you want to grid.
So when you're doing that, when you're starting your scan, you go, forward 20 seconds. I don't know. Do you have to come back and start over to your next scan, or can you just turn around and come back? Will it build it that way up and down, or you got to go the same direction every time?
We can put that setting in. Yeah. So we can put that setting in there to be able to turn around and run your next line backwards. It's just either this way or that way. It's
got to program it how you're going to do it.
Yeah, we just haven't added that setting. And kind of one of the reasons is doing it. I did scanning for a living, I did a lot, not just play. And we did it on the largest grave site in North America, on the West Mesa grave site outside Albuquerque. We did it for the Albuquerque police out there, looking for graves and whatnot. And I know from experience that anytime you come back another direction, everything changes to some degree because everything is polarized. And all these fields follow polarization. It doesn't matter if it's an RF induced field, like a metal detector, or if it's the Earth's EM field. As you approach it different directions, data changes. And why complicate it?
So it's always best to go the same direction.
Yeah, right. Absolutely. Because the relationship of your scanner is the orientation is the same to the field. Because the Earth's field's flowing all the time, and you have all these other fields coming off the objects and items, and they're like a river, you're seeing it through a river, and some things, or better yet, you're seeing an object in a fire, and in front of it, it'll build up and compress, roll around the edges and have a hollow spot, behind where the flame is. Well, that's just what you're seeing in the Earth with passive equipment. So if you turn around one direction, it's coming across your scan one way, you turn around, it's coming across the scan the other way, or it's going with your direction and against your direction. That's going to absolutely put too much change to trust data. And people see it all the time. If you guys out there, whoever's watching this, has an OKM device, if you haven't seen banding in your scans yet, and then wonder, how come there's always this banding? There's two reasons for that. Either one, it was out of step at a turn, or two, that's the changes in relationship to the magnetic field. And so one will show up green, the next one's blue, the next one's green, the next one's blue, and then it breaks. Each time you have that band, it breaks the signature. So no longer is one signature contingent anymore. What if there's a corner there? That's gone. So, this is where the problems in all this software that they've developed comes up. And so I'm not keen on that. Taylor was going to add it, and I was going to get beta testers to talk to me about it and stuff like that, and I just wasn't keen on it. One thing that's cool about this software is when I run a scan, let's say there was a tree, right? And what are you going to do when you get to the tree? Let's say it's in the middle of your grid. What are you going to do? I can deal with that with this software because I can stop and actually start a line really anywhere I want once you know how to use this. And you could have a hollow spot in the middle of the grid, and that's where the tree is. So, and it'll just show up as a negative value because it's a negative value. You didn't take a scan. So as well, you can, let's say you walked 2 paces over on a line, right? Now doing the sample count like we do, you're not normally going to have that issue or whatever unless something occurs, whatever, or you stop a scan, but that'll show up on the grid. So instead of like OCAMs where it'll just make the whole thing fit, and even if you went a pace over, and it'll mess up the rest of the scan, this won't do that. It'll show on that bottom grid, it'll show that 1 foot off the grid. And so it doesn't change the grid. It's an actual representation. Even if you screw up, it's going to be an actual representation of what you did. Same thing as you can just go erase a data point off the grid, off any grid there is. If there's a problem, just go in the file, erase that point. It's an XY point. You can look at it, and it'll just take it out, and it's gone. And then you'll end up with an empty square there, and it doesn't mess up the grid. It doesn't mess anything up.
So a couple questions for you then.
Mm-hmm.
So what is this going to cost, and how do people get a hold of you? And tell me more about this beta testing. You got you're already filled up with, or you need some more?
We're not filled up, and we want to fill up quick because we want to begin and go on to the next stage and not have to worry about signing a bunch of people more people in. But to get on as a beta tester right now, we've got 2 packages available, and really nobody's gone for the first package. I don't even know why we have it, but we have one where it was just going to be the software itself for the PC. And so then when people get whichever they're going to use down the line, they don't have to buy that additional. The second package is the software and the app. So you get a phone app with it, because we are going to have the app all by itself, because some people will just want to use the laptop and not use the phone at all. And so you can save money doing it this way. And so we have basically the best option that we're pushing is a $200 option where you get the software and the app, and then you get 50% off on the device as soon as it comes out, and 50% off on the high tier subscription stuff, to where you're in the deep learning program with all those tools and us and everything else. And then the lesser tier is $100, but it's just for the software. And then it gets you a basic level subscription, which is going to be all your updates, and we give you feedback and assist as we can, but it doesn't include like training. The actual training is stuff will go on the other deal, because it's more of a relationship we're going to build with who we consider our field researchers, right? Because they're going to be using this technology and feeding us information back that we can program the AI with, if you get where I'm going with that.
Yeah.
So some guys are just going to want to be raw hobby user. We got that for $100. Take your laptop, plug your metal detector into it,
So for this beta testing, what are you getting this device that you can plug into your detector, your 2-box, your whatever?
Yeah, and I can show you that device too, Terry, if you want to see it real quick. Or where we're at with that device anyway. Just take me just a second here.
So while you're digging that out, John, man, if I get this beta testing thing, you gonna help me beta test this thing out?
Yeah, we can put it to the test. What is the frequency range that this can look at?
It shouldn't matter, huh?
No, it doesn't matter. We can actually dial it into. That's because it's underneath me here. Let me raise this up on the scale.
Well, I think, John, it just depends on the frequency range of what device you're using. And then there's another question for me, and I don't know if there would be any advantage or not. Does your ground penetrating radar? It does not put out a sound. It's strictly whatever rays it shoots down into the ground, right, John? So this would not work for a ground penetrating radar.
Well, you could grab the data and convert it to sound and then put it in.
Yeah, real easy, because this is taken as raw spatial data like anything else, X, Y, and Z. And then our other information is not necessarily to plot a ground map. It is for the deep learning to do work with it, but you can manually feed some of that information in, dielectric property of the ground and some of that other information. You can feed that into it. And we'll have that option available here pretty quick, where we can actually talk to the program a little bit more than being pure auto. So yeah, it'll work with any spatial mapping at all. That's what we wanted to do, is create it to where it'd be open source with very little conversion to scan with your georesistivity, your pulse induction, whatever you want to. And then we're going to be programming all those parameters into this software. So it knows what pulse induction is, basically. So, but yeah, you can map with just about anything and get it into this. It's just this interface allows you to use anything that puts out an audio tone, which is, just about every handheld detector and mag and stuff. So
So put me down for one of them,
yeah, okay.
Robert. But so I can see if if this is doing what you're telling me, if you can get it to go where you're saying this is going to go, man,
Hmm.
this will revolutionize everything.
Yeah. Well, you already saw an image I did on my floor with my metal detector. That's with a White's Classic 3, and we don't just see the nail. We see ground difference. We see what we're looking to see. If we didn't see that difference, there wouldn't have been blue there. The data obviously dropped and showed us that something was below the medial standard there. So there it is, and I've done bigger work with it, so I'm confident what it'll be. I mean, I've done bigger stuff, but just to show you those test files or whatever, yeah, that's the thing. It's kind of like not if it works at this point. It works. It's kind of hard to believe, but it works. Now the developer, he flipped. I'll be honest, he flipped, and I know him real well. He used to be on our team. He's done digs with us. The developer from OKM here in the States, and
What do you say?
he flipped because they did this. They invented it. Oh my God. He goes, I never thought of that before. I said, tell me, is all the data in that audio signal? I said, it is, isn't it? I said, that's just straight off the sensor, isn't it? He goes, yep, goes through a tone generator. I'm all, yep, there you go, bro. He goes, this thing's going to work. So yeah. And I've already beamed him back, the, our GUI, which is the graphic user interface, that we just showed you. And so he's really excited. He's a neat guy. He's a pretty cool guy, for German. No, I like Germans. They're all right, but he's
Cool. So I can tell there's some spots, man, that I would love to hit with this on a
Mhm.
on my 2 box, and with I have a friend that has one of them rovers,
Yeah.
and on that I've got some places, man, that this would be great because I could see there was flaws with that OKM, and every time you went to use it, you had problems, and
Especially getting him to link up, you
yeah,
know,
yeah,
and
we had that problem all the time. So I
yeah, and I'm going to bring up a picture of the device again. Can you see that?
yeah.
Yeah. So this is of course it's a 3D model of the device and all that, but those are all the components that go in it. There's their place where they go and everything, and we're already printing my first prototype stuff. Taylor has all the boards. I think we just lack like the GPS module we're going to use, and the GPS module almost doubles the price of the device. That's
Yeah,
the only
yeah.
bad thing because yeah, you can throw in a GPS sensor, no problem. We're not doing that. We're throwing in this millimeter accurate, that also uses a gyroscope and all this other stuff to
Wow.
annotate its position. And so, because they're from the little drones that need extreme accuracy. So,
So you
so
need
that's what
to
we're using.
attach it to whatever so that
Yeah.
it's measuring the
Yeah.
angles and all
Yeah.
that.
So, like a detector with this device, instead of having it out sweeping, you'd turn it straight up and down and use it just the way you would a mag. So its GPS is straight over your scan position.
Yeah. And what
Yeah.
everybody's seeing here is it's all pulled apart. And when
Yeah.
it gets all together, that all collapses into that little box, and that's the lid on the other side, and it's all cool.
Yeah, and basically like a real quick view. I got these are renders of what the device would look like here. So um, let's see if it'll show for us. I think I have to.
So what I was getting at before that, I got a lot of spots where I'd like to test this, but it's under snow right now. So I'm gonna have to figure out some other places I can take this and test it. But in the summertime, man, I can see I got a lot of places, man, that this would be, if it's gonna do what you say, man, this is gonna be great.
Yeah, and basically you're looking. This is kind of a little view of the some of the mock-ups, but it's just going to be a self-contained little module. And it's a little different dimensional quality than that one, but really this is what it is, and all you really have here is an audio input and a USB, and the USB will do it'll do data connection if you want to do it that way, or Wi-Fi. So if you don't want to do a Wi-Fi signal, or your device is Wi-Fi capable, then you can plug it in direct with a USB. The USB will also act as a charge port. It'll also act as a data interface for updating the program or whatever. And then really just the audio hole. And that's it. So
So with the rover seeing that, it's gonna detect voids for you. It's gonna detect all that stuff.
Yeah. Yeah,
Wow.
and our device has the program will also all be in the device, and it'll have a large memory cache inside that little box so that you're not using the resources of your telephone or your tablet or any of that. Really all that acts for is a screen. The image and everything is generated from the device itself. So that's really a standalone. We could put we could not a general monitor, but a computer monitor we can put on this thing and run it. So you don't really need your other stuff with it. And eventually we'll have a screen we put out with that little box. So you can put the screen on the detector, the box on the detector, and run everything right there in your detector. You don't need a phone, you don't need a laptop, you don't need a tablet, nothing. So that's eventually, because like I said, that little box contains the full program. So that's where we went with that. And it just makes it easier and
So
more.
how far away are you to having that little box um, ready to go for the testers and all that? I mean,
To
you
ship it out, probably realistically, by the time we get the cases printed and figured out and get all the little tweaks and stuff done, because that's literally hours. That's more hours than not programming, but anything else. I would
just build them.
say
Huh?
3 weeks.
And I know, man, you're a 3D building guy, man. You're probably building all this lots of this stuff yourself.
No, everything. Yeah, we build everything ourselves. So we print all kinds of different plastics in house. So PETG, ABS, um, nylon, carbon nylon, TPU, which is polyurethane rubber. We print all kinds of stuff. So, and we will have a rubber case for this as well, a ruggedized rubber case that's TPU rubber that'll snap on it. So if you want to bang it into rocks and stuff, whatever. The case is going to be printed out of high temperature, high impact PETG plastics, and they're super friendly plastics. They're actually non-toxic and food grade and all 9 yards. So yeah,
Cool.
yeah, we
So
thought about it. So there's a lot of thought went into this, man.
so man, I told you guys, Robert's a smart guy, man. Now he's even smarter than I even thought. I knew he was a smart guy. But how do they get a hold of you, Robert? How do they see what you're doing? How do they, tell them about your website, your YouTube channel, all that stuff?
Well, what you do is, I was gonna bring up something else. Let me just throw this in the corner. How about that? That's
That
cool.
works.
And I was gonna bring up I was gonna bring up an information card, but I don't think I have it available. It's not where I thought it was. So you can get a hold of us. You can always search my name, Google, Bing, whatever, Robert Kryder, and Kryder, or you can look up Kryder Exploration very easily on those as well. And you can we're on Facebook, we're on YouTube. On YouTube, it's KX Kryder Exploration, but simple search will find it. We have a couple of research sites. Generally, like Terry said, I do the Bigfoot thing or whatever, but that was so we have some Bigfoot research sites on Facebook as well. You can find that by searching KX Cryptid Hominid. And then just Kryder Exploration on everything else. So we have a website at kryderexploration.com. And if you want to see more on this technology, we can beam people a link. I don't think I can just yell the link offhand here, and it won't search out yet. I tried that, but so we're on Wix is where our site's based, and it's Geo Pro 3D. And but you get a hold of me, and I'll beam you a link to this. You get a hold of Terry. I'm sure he can beam you a link to it until he gets set up a little bit better, and we can get you information, get you in there. And we'll also have a Facebook group here probably by tomorrow. I'll probably do it tonight before I get off for the owners and operators and beta testers, to where the beta testers can go back and forth with us, and the public can watch this exchange of information, get tips, tricks, learn all these things between the people figuring out what we can do with this technology. Like I said, I don't know what all we can do with this. All I know is it works. And so, look at the vast array of detectors and how they generate tones and all these different things. And we are going to develop methods for all this to work. So it's going to be a pretty neat deal just being a part of that. And I think a lot of you guys probably want to get into it. So, because you're going to see what's this look like when this guy scanned it with a, MindLab, GTX 6000 or the Go 60 or whatever, a Fisher 2 box or the old Geminis, and what's all this going to be. And so it's going to be a neat experience. So I invite everybody into that. When you get to the company website for the Geo Pro 3D, In there, there's applications for, and they're just being set up for courses, a 15-step course to get you aware of geomagnetic theory and how to understand the stuff, kind of what we've been talking about a little bit this evening. We have, like I said, we have an event that's going to be coming up that's an in-person seminar deal. And then as well, we have services like consultation, and the prices aren't really set right for everything, but we have scanning imaging surfaces. We will come out and do the imaging for you if you don't have the type of stuff, and all this is going to be under that same umbrella. So
Cool.
cool.
Well, Robert, man, you got any last words or anything you want to say?
Not really.
Hey,
No.
with that,
Thanks, you guys. Thanks, Terry. Thanks everybody for being
Robert,
in
man,
here.
I appreciate you, and man, this sounds like this is going to be a revolutionary thing, and I'm excited for you, and I'm excited to see where this goes and what's happening. And with that said, that's a wrap.